In Physics 103 and 104, when we talk about log, we mean log to the base 10. Mathematicians often use what are called natural logs, which are logs to the base e. Now, base 10 logs, the log to the base 10 of 10 to the x, which in our notation, since we only use base 10 logs, we'll just call the log of 10 to the x. It turns out that the log function undoes the 10 to the power of function, so you simply get x. For example, the log of 1,000 is the log of 10 to the 3, because 1,000 is 10 to the power of 3, and so matching the pattern above, we see that the answer would be 3. Also, since log undoes 10 to the power of, 10 to the power of undoes the log, so 10 to the power of log of x ends up equaling x. An example of this is 10 to the power of log of 1,000, and according to the pattern above, that should equal 1,000. And to see why, we can go like this. That's 10 to the power of log, and 1,000 is 10 to the 3. The log of 10 to the 3 is 3. This is 10 to the 3, which is 1,000. So what about the log of numbers that are not powers of 10? Well, this is where it gets interesting. The log of 2, for example, if you use your calculator, you'll see you get 0.3. And very similarly, the log of a half, so the reciprocal of 2, turns out to be a negative number, negative 0.3. And if 2.5 are intensity ratios, we call those numbers on the right hand side bells, named after Alexander Graham Bell. Now in this course we don't use bells, we use decibels. And a decibel is simply 10 bells. So if we just multiply the above two equations by 10, we'll get decibels. So we can have 10 to the log of 2. Well, that's going to be 10 times 0.3. And I want to make really clear here that it's positive, so I'll use a positive sign. 10 times 0.3 is 3 decibels. And 10 times the log over half is going to be 10 times minus 0.3, which is minus 3 decibels. Now I do realize that the minus 3 are not exact, but it's pretty darn close. It's 3.01. So it rounds off to 3 or 3.0. So that is how decibels are related to logs. So now that we know the relationship between decibels and logs, what specifically do we need to know about decibels for this course? Okay, so the definition of a decibel goes like this. 10 times the log, remember base 10 log, of the ratio of two intensity levels. Call them I2 and I1. Is what a decibel is. We'll use the symbol beta. The units of beta are decibels. As an example, a couple of examples here. If intensity level 1 is 1 watt per square meter, and those are actually the units that sound energy is measured in, and intensity 2 is 4 watts per square meter, what is the difference in decibels? So if we calculate beta, it will be 10 log of 4 over 1, which is 10 log of 4, and in your calculator you'll see that this comes out to 6, and in particular it's positive 6. In fact, any time a certain intensity level is 4 times greater than another intensity level, the difference we say is 6 decibels. Every doubling of intensity level gives you a 3 decibel increase. So for example, if I had 8 watts per square meter compared with 1 watts per square meter, that's 3 lots of doubling, so that would be a plus 9 decibel difference. What if the intensity is going down? So what if we have intensity level 1 is 4 watts per square meter. And intensity level 2 is 1 watt per square meter. Okay, the decibel calculation will be 10 log of 1 over 4. So when you calculate a 10 log a quarter, and that turns out to be minus 6. So that tells us that a quarter intensity level, or if the intensity level is less by a factor of 4, we go down 6 decibels. And you go down 3 decibels for every halving of an intensity. And if we had 1/8 of the intensity, that would be minus 9 decibels, because it's 3 lots of halving, so 3, 6, 9. So what if we know the decibel change and we know one of the intensity levels and we want to find the other intensity level? Well, this is where the math generally gets tricky. So from the equation at the top, we can derive another equation. And this is where the math gets tricky, so I'm going to do this in a different color, dark red. Dividing the top left equation on both sides by 10, we get the log of I2 over I1 is beta over 10. Now remember that 10 to the power of undoes the log function. So if we take 10 to the power of both sides, it becomes this. 10 to the power of the log of I2 over I1. So 10 to the power of all of that equals 10 to the power of beta over 10. Now since 10 to the power of undoes the log function, on the left hand side it's actually just I2 over I1. And the right hand side doesn't simplify anymore. And then multiplying both sides by I1 yields I2 equals I1 times 10 to the power of beta over 10. Couple of examples working with this equation. If the change in intensity level in decibels is plus 20 decibels, and intensity level 1 is 4 watts per square meter. Intensity level 2 will be intensity level 1, which is 4, times 10 to the power of beta, which is 20, over 10, which is 4 times 10 to the power of 2, which is 400, and that'll be watts per square meter. So an increase of 20 decibels is actually an increase of 100-fold. Okay, what about for negative decibels? If we have a negative 20 decibel change in intensity, and intensity level 1 is 4 watts per square meter. Intensity level 2 will be 4 times 10 to the power of minus 20 over 10, which is 4 by 10 to the power of minus 2, which is 0.04. That'll to be watts per square meter. So a loss of 20 decibels is in fact a reduction by a factor of 100. Now, every 10 decibel increase is a factor of 10 increase, and every 10 decibel reduction is in fact a factor of 10 reduction.